Hey guys, so in this question we are looking for the probability of the individual's blood pressure, right, between 118.2 and 121.2, right, which is this expression over here, all right. So now what we have here, if we read clearly here, we can see the mean of systolic blood pressure, all right, is 120, okay, and the standard deviation is 5.6. Moreover, here we starting with a normal distribution, okay. So if I want to graph this, we are starting from a normal distribution, having the mean 120, all right, and standard deviation is going to be 5.6, and we are looking for between 118, so 118 is going to be somewhere here, and 121 is going to be over, so we are looking for the area in between. So this probability is the area in here, okay. So what we're gonna do is we're gonna standardize it. So we're gonna go to a standard normal distribution where the mean is 0 and sigma is gonna be 1, and then we're gonna figure out what are the equivalent values here, z1 and z2. And then we're going to transform the same area, right? So to move from this area to this area, we use the standardized formula, which is z is going to be equals to x minus the mean divided by sigma. And we notice here we don't have a sampling, so there is no radical n. So if you're going to use the formula, see, this is the formula from your chapter, all right. So definitely you don't have a sampling, you're gonna use a standard score formula, which is x minus the mean divided by z, all right. Okay, so let's get into it. So now the easiest way to do this question is you're gonna be the probability, you're gonna write the values 118.2, leave a space, x value, leave a space, and 121.2 and leave a space again. So what we're going to do here, we're going to take away the mean, and then we divide by sigma, and we're going to do exactly the same thing with the other two values, but we're going to plug in the actual values, right? So whenever we take the mean here away, which is 120, we take away 120 as well from this side, and whenever we divide by sigma, all right, sigma is 5.6 and 5.6. So we can end up with a probability here again equals, so this value is going to be here, this expression, it became z value, and this value is going to go here, and we're going to look for them using the calculator. All right, so don't forget to put a parentheses on the numerators. So this is going to be, open a parentheses, 118.2 minus 120, close the parentheses, and divide by 5.6. So the first value is going to be minus 0.3214, so 32. We need to round to 2 decimal places for the z value, and then we're going to do the same thing, so we can reuse the same formula, and then we change the 118.2 to 121.2. all right, enter, and this again be 0.214, so if you round it 0.21. all right, great. So the reason why we centralize this, because this is coming with a table, so the standard normal distribution is always coming with a table. So we're going to go back to the question. We're going to try to pull out the table. The table, you can find it here. And then you're going to read the values as they are. So if I have minus 0.32, so you're going to be minus 0.32. So minus 0.32, minus 0.3 right here, and 2, which should be the third one. So this is going to be 37.45. So the equivalent value for this one is 37.45. We're going to do the same thing, the equivalent value for 0.21. So 0.21, it should be on the other side of the table, the bottom one. 0.21, 0.2 here, and 21, you're going to be 58.32. Right, so the probability here would be the biggest probability, which is 0.5832, minus the smallest one, which is 0.3745. Plug it in the calculator. So 0.5832 minus 0.3745, and enter. So this one is going to be 0.2087. all right, so let's verify the answer. Plug it in. Okay, great. So this is correct. Let's try to go to the second one. All right, so on the second part, they are sampling. So they're gonna take a sample of 37 randomly selected, and we want to find again the probability between 118.2 and 121.2. However, here they are not asking for the blood pressure, they are asking for the sample mean. All right, so the sample mean, that is a different story. That is not x, this is x bar. All right, and for this reason you see here that the probability here that the x bar is between 118.2 and 121.2. Okay, so I wanted to make a difference between the two questions. Here they did not ask about the mean of the individual blood pressure. They ask about, here they ask about the blood pressure directly. They didn't ask about the mean, so they added the word mean. All right, and that's make a difference. Okay, so let's see. I'm going to try to explain it again with the graph. So what we have here in this scenario, we're starting with the normal distribution, still the same one. So the mean is 120 and 5.6. So this is the mean, this is sigma, and this is the x-axis. So by doing the sampling, n equals to 39, we are actually using the central limit theorem. Central limit theorem. All right, and this is gonna give us another normal distribution. However, the axis here is gonna be x bar. The mean, the new mean, or what we call the mu x bar, this is gonna be 120, same one. However, the sigma is gonna change, which we call sigma x bar, and this is gonna be the old sigma divided by radical n. All right, now once we get the new distribution, all right, so this is a normal distribution, we get another normal distribution, and then we're gonna do the standardized formula. And if you standardize it right now, you're gonna get another normal distribution. All right, the formula here we're gonna standardize is the z equals to the x bar minus the new mean, which is mu, and divide by the new sigma, which is sigma divided by radical n. All right, and once we do that, we're gonna get the mean equals 0, sigma is gonna be 1, this is the z-axis, and here is the standard normal distribution, which means it's coming with a table of values. And once you get the table of values, you can get the probability. So as you see, it's a long way to go all the way there. However, the application is not really complicated, so we're gonna use probability here. You're gonna write the numbers as they are, leave a space, x bar, and here 121.2, and leave a space. So what we're gonna do here, we're gonna take away, we're gonna apply this formula. All right, we're gonna take away the mean divided by sigma radical n. All right, now for the other two values, we're gonna plug in the values of the mean, which is 1 minus 120, and divide everything by 5.6, that's the sigma, divided by radical 39. Don't forget the parentheses. And I'm going to do the same thing from the other side, so 5.6 divided by radical 39. So what's going to happen here, this value is going to be calculated by the calculator. This value over here, it became z, you can see it here, and this value is going to be calculated with the calculator as well, so we can use the table and we can get the probability. All right, so let's do the calculator part. So here I'm gonna start with the parentheses, 118.2 minus 120, close the parentheses, divide by, open the parentheses again, 5.6, and divide by the square root, second squares, and 39. Exit the square root, close the parentheses, and enter. This is going to give you minus 2.007. I need 2 decimal places, so I'm gonna do minus 2.01. For the second one, I just need to reuse the same formula. I'm gonna go to the first value and change it to 121. All right, 0.2, enter. So you're gonna give me 1338, which is 1.34. So again, I'm gonna use my z values table. Minus 2.01. This should be minus 2.0 and minus 2.01. You're gonna be right here. So you're gonna be 0.0222. I do the same thing for 1.34. I go to the table 1.3 and 4 should be here. So 0.9099. And then finally I'm going to take the smallest probability from the biggest probability, so 0.9099 is here, minus 0.222 here, and this should be my answer, right? All right, choose the calculator again. 0.9099 minus 0.0222, and the answer is going to be 0.8877.